Okay, so thank you all for coming to this talk. I hope you find it interesting and you can take something away from it. My name is Nadia Ashahwan, and I'm a software engineer at Facebook, and I work in a team called Sapience. So my team is trying to... So what we were thinking is, imagine if, as a developer, you didn't need to spend any time testing, writing tests, or testing your code, or even maybe fixing your bugs, right? All you had to do is just spend all your time on creating new things, new features, thinking of new ideas and implementing them. And then let the machines take care of all of the testing and debugging, and also maybe fixing the bugs. Especially if you think about it, a lot of the bugs are, not a lot of the bugs, but there are many bugs that are common, like a condition on like so it's kind of an edge case or something that you missed out, something wrong with the indexes, or you didn't check for a null pointer or something like this. So you can kind of imagine that a machine can probably take care of a lot of those things. So so we all use apps, we all use phones, and if you do, you're probably familiar with this, where you're using an app, you're doing something, writing a comment, looking at pictures or something, and then the app crashes. It's really frustrating, and it wastes time as well, right? So you navigated all the way to a certain point, and you started typing or doing something, and then the app crashed. And now you have to start over again. And in some cases, it could also be a transaction. And then you just kind of maybe wanted to, like something goes wrong, actually. Money goes to the wrong or something. So we don't want apps to crash. And we definitely don't want those crashes to make it all the way to prod and the users find them, right? If you think about like the development life cycle all the way to release, and how much effort you need to fix a bug, the further away it is the further along the process it is. So for example, so you can see it goes up, right? So if you're writing code and there's a bug and you find it, it's very easy to fix. In the context, you just remember what you were doing, just change the code, that's it, right? But if as you go along the process and it goes all the way to release, then it's very time-consuming and takes a lot of effort and a context switch because you're working on something else and now you have to go back to this thing you did a month ago and try to debug and find out. And sometimes it's really even hard to find out because there's like thousands of changes and you don't know which change caused this issue, right? So what we want to do is to push this. We want to find issues, we want to find crashes specifically as early as possible because that will save us time and resources and everything. So when you use a code review, that's a chance for, so other than testing and stuff, code review is a chance for other developers in your team, other people in your team to look at your code and find issues that maybe you didn't see because you're so in this zone that you can't see the bigger picture or something. Or maybe they have knowledge of a different part of the code that is affected by this, or someone else using the same code. But the problem is that when you have a really big code base, like for example what we have in Facebook, it's really hard to have context over everything, right? And then everyone's busy and maybe someone has been working on something for a while, you don't know why they're working on it, and then you start seeing maybe people accepting things, like not noticing all the bugs and crashes, and so all the bugs or issues that might cause crashes. So the way we think about it is that this is a scalability issue, right? And automation is very suitable for scalability. If you need to scale something, if you automate it, then that's a good way of scaling. So what we were thinking about is if we have automated testing or some automated testing running on your diffs, and then but developers or something just kind of commenting on your code. Maybe that way we can catch more issues before they make it to production. So in Facebook, we have a few tools doing this. We have something called Infer, which is a static analysis tool that finds a lot of things through static analysis and comments on the diffs. But we also have Sapiens. Sapiens is a test design and execution engine, right? Because if you think about writing, so we talked about this, I talked about this a bit before, it's like when you think about writing tests, it's very time consuming. To write a test is very time consuming, and it's very tedious, and it's boring probably, or something. You have to think of all the cases, and you might miss something. So so it's a good candidate for automation. And when we think about what are the qualities of these tests we want to write? So the first thing is we want them to have high coverage, right? So we want to cover all the features you have in your application. We want them to cover, so you can think about it as like all branches. I want them to cover all branches. I want them to cover basically all the code. But also there are other things, like you want them to cover different devices, different operating systems, different combinations of things, different maybe network settings, and so there's a lot to think about in terms of what different combinations you can test, right? The next thing you think about is that the quality of the test has to be high. And one issue that we struggle with, and it's very hard, is the flakiness of tests. So a test is not reproducible. So you run it, something happens, you run it again, something else happens. Sometimes it fails, sometimes it doesn't fail, just based on, because like, for example, let's say it was a race condition that caused the crash, right? So it's just because the test was executed in a certain speed and the network, something happened and then there was a lock. You might run it again, that doesn't happen because that depends on some randomness in the execution itself, in the environment that caused that. And then there are other elements that are part of the app. For example, if you think about Facebook, you get news feed. So let's say you're logged in as a user, you get the news feed. It's not deterministic. It depends on the time of day and what's trending and what is. So although you are entering the same inputs, the environment is responding in a different time. So in a different way. So we have to think about all of like how to control this flakiness and how to have high reproducibility of our tests, because that's how people can debug things and can even have some confidence that they fixed the issue, because I run it again and I have confidence that if it doesn't crash again, that means that it's highly likely that I fixed it. While if you have really flaky tests, then you don't know, basically. It could be just that one run. And also that the tests need to be maintained and updated regularly, because if the app structure changes, if the buttons, the names of the buttons, whatever, if it changes, and then your tests will become obsolete and you have to update them, right? So it's good to generate those tests automatically, because otherwise, like you're going back and changing like the names of the buttons or something in your test scripts. The final thing is that we want to also test unexpected behavior. I'm sure we've all been in the situation where there's a bug, and then when you look at the scenario where it happened, like there's a bug that happened in prod, and when you look at the steps the user followed, it's like, why would anyone do this, right? Why would you do these steps? Why would you do this and then go back and do this? But that's exactly what we want, is to because if you have millions or billions of users or whatever, they're bound to be things you don't expect, right? Even if you have 1,000 users, they will do things that you didn't expect. So people tend to write tests that are what they expect the usage will be, while maybe machines, because they're machines, they will just do random things, right? And then do unexpected things and find things that you wouldn't find when you do when you write the tests yourself. So that's why we have Sapiens. So Sapiens is a tool that it started as a startup. It was a university. It was like someone's PhD. It uses search-based software engineering, which is like genetic algorithms and stuff. So it's a field that has been around for a long time. and it tries to generate tests using that. So it simulates, so I'm going to talk about the details a bit later, but so basically this tool will log into to an app, so the app we're testing, it will log in, it will simulate a human. So it will start using the app and clicking things and doing things and typing and whatever, like doing different actions to try to crash the app, right? And once you crash the app, once it crashes the app, it will go and look at the stack trace and try to reason in a very, at the moment, very naive way about like what caused the crash. So we'll just look at the stack trace and think, okay, which one of those changed most recently, right? And then go and see if in that diff the line is close to where the crash happened or something, and then comment on it and say to the developer, can you have a sanity check? This is the crash. Sapiens found the crash. This is the video. This is logcat. This is all the logs from the servers and everything. This is everything we have on this crash. Can you check, right? And we found that in many cases. So it isn't accurate because you're just looking at what changed recently, right? So if someone had, just put a new line or something there, or just kind of change the name of something, then it would notify them, although they have nothing to do with the crash, right? But it's kind of okay because we feel like if you worked on the file itself, then maybe you have enough context to fix the crash, right? So it's like it doesn't have to be caused by you for you to fix it, because we all want our apps to be better and of higher quality. So maybe that person would fix the crash. Okay, so I should have clicked this before. Sapiens. Okay, so like I said, the Sapiens crawls through the app and tries to simulate a human, click on different things until it also tries to do things like just kind of click quickly, go back and forth something. So it's kind of maybe not very realistic as a human, but as a human simulator, but we found that makes us find crashes. Okay, so how does it, so the way it's like the setup of the environment is that we have Sapiens, and then Sapiens talks to a service we have at Facebook called OneWorld. And OneWorld is a provider of like runtime environments, so simulators for iOS, emulators, and even devices. So you could just and browsers. So all you do is like say to OneWorld, give me an emulator, and they will give you one. They take care of everything, right? Creating it, making sure it's alive. Even if it dies, they will. So it's all like separate. So we don't have to worry about that. All we do is say, give us an emulator. And this is the way, like on a high level, it works. So there's a test engine. It will, first of all, start the app, get some information about the environment, like what's on the screen, what are the different elements, which ones are visible, like what all the information is, basically like just a dump from the screen. And then it will decide based on something. Right now it's like very simple. It's just like what's highest on the screen or something. What to click. It will click it, not necessarily click it, put text in, tap, swipe, whatever, do something, do an action, and then inspect the state again. And then just keep going until you reach the limit. So let's say you said, I want 200 events, it will do 200 events, right? So you tell it how many clicks you want it to do, right? So, and this is all through communicating with this OneWorld service, which has the runtime, which has like the emulators and also some controllers around that to, like I said, to monitor that, or the emulator crashed, right? So now I need to restart it, save or something. So it takes care of all that behind the scenes stuff. But if we look at like dpad, so Sapiens itself, it has 3 features, right? So three main features. Okay, a second. click too quick again. So the first thing is that, so it's kind of define actions as maybe a pattern or something, because there are some actions that you need to do in sequence for you to have an effect. So for example, if you have a login screen and you just kind of, you have to just click the login, that's different to, like maybe it wouldn't get you to the next step that you want to get to, which is like you want to enter the username, enter the password, and then click login. And it's the same for any form, right? So anything, any box to do something and then submit or OK or whatever. So you want to do these actions together so that something happens, right? So that's one thing. So it's kind of, you can define these gestures that are like a combination of clicks or text or something, and say, okay, if you see this, or you can define it in a way that is more generic. So you say, oh, if you have a few elements in a tree, then they're probably they're like with the same kind of parent and everything, then they're probably things to select in one list. So just click one and then find the closest button or something. The next thing is, so this is how, so this is just like the unit of things to do. And then, so following what I said before, it will generate a number of just random tests, right? So let's say you told it do 10. So it'll generate 10 random tests following that approach. So click, do something, check, click, check what's on the screen and click. And then after that, so now we want to improve those. So these are randomly generated. We want to improve them. So how do we improve them? We define something to rank them, right? So for example, for us, it's just coverage right now. So it's like how much branch coverage did each one achieve? The ones with higher coverage are, for now, better, right? So it's kind of rank based on coverage. Then we can select the best ones, like maybe the best one or two or something, and then try to do something with them. So let's say we have two sequences. The first sequence at the beginning did a lot of good things. It covered a lot, and the coverage was going high really quickly. But then after that, it started doing just redundant, kind of going in cycles or something, just going to the menu and back and something. So the beginning is good, but then that second part is not that good, right? But then I have another sequence which actually starts from that same state in the same screen in the middle, and then does something interesting at the end. But the beginning was really not interesting, or not as interesting in terms of coverage. So it's not as good. So what you can do is like maybe chop up because you have that state, the common state in the middle, you can just cut them up and just swap them, right? So then you will have one good one, where it starts really good and then ends really good, and then you have another one which is like completely bad now, or just completely. So you can drop that one. We don't need to save it. We'll just keep that. Another thing is you can do something called mutation, which is just kind of like, let's take one event and change something about it. So maybe change the text you entered, or instead of tapping, do a long tap, because that sometimes opens some hidden menu or something. We're still evaluating if this is useful, because you can think about it, it's like if you change one event, maybe everything after that will change. So it's kind of like you could have just got to that point and did something else. So we're still evaluating all these kind of how do we, and trying to think about like what can you do to if you have a number of test sequences, what can you do to make them better? Like what can you do to generate better ones from them, right? So one thing could be that you can, one thing we're looking at right now is like you can look through the sequence of like the things you've seen as you go along. So let's say this sequence has good coverage, but when I was in the 5th screen, there was 100 things to click, but I only clicked one, right? So it would be very useful to go back there and try like other things, because there's a lot of uncovered. So maybe let's say it's a settings menu, and then there's a lot of links to a lot of buttons to click and follow. So you can learn something about the environment and then use that in the next run. So it's kind of, okay, that sequence, if I go back and replay it, and then, but when I reach to point X, I want to do something different because there's a lot of potential there. Um, so we use coverage right now, but you can also have more than one objective, right? And then if you have more than one objective, then you have to balance them, right? So let's say if you think about it in terms of, so coverage is one dimension, and the other dimension is you want the sequences to be short, right? Because if the sequence is shorter, it takes less time to re-execute. So if you want to do regression testing, you don't want something, if it's 50,000 events and it takes an hour, but then I have one which is just 100 and covers the same thing, I want the one that is just 100, right? Well, not necessarily, but let's say, because it's quicker, and then I can get the same coverage really quick. So you can, when you evaluate, you can have more than one dimension to think about. So use kind of coverage over length. So how much value per click are you getting in terms of coverage? And then if you plot all the sequences that you have like this, yeah, they will look like this, and then you might have points here where, like in the bottom. So these are all, if you think about it, if you don't, if you have no preference, like if two objectives are of the same importance to you, then all of these are candidates that you should save because they're like the best ones you found. Anything below that, like anything, if you have two, so if you had a point here, for example, then that we don't, if you have a sequence that is plotting here, then we don't care about that one because it has less coverage and it's the same, so it's the same length as this one, but it has less coverage. So why keep it? We'll just keep this one. Of course, there's things to consider, for example, that what does it cover, right? Because if it covers something else, even if it covers less, then it's still important. So it's all about thinking about your objectives and what you want to do. But the whole process of improving the sequences is to try to push this line further out, right? So we want our next generation to be plotted here instead, right? So we want to improve on both dimensions at the same time so that we can drop all those, and now we have these better ones that have higher coverage and higher coverage per click sort of thing. And we just keep pushing this out, right, until we run out of time, right? So let's say we want to run for half an hour, that's it. After half an hour, wherever that line is, we can save those sequences. In reality, we save all sequences just because it's cheap, right? And then you might have like the ones below that are maybe covering something different that the ones better are not covering, so it still have some value. But when we select, we favor the ones. When we select to do testing, we favor the ones that are better on both dimensions. So, what we want to achieve is that we have smart tests that are high quality, not flaky, like very highly reproducible and with low latency. What we want is that you submit your diff and like as quick as possible, we test it and tell you if there's something wrong. So we want it to take, like ideally we want it to be instant, but that can't happen. So it's like, let's say we want it to take 10 minutes, 15 minutes. We want to comment on your diff before humans start reviewing it, because that will save them time. So if you submit a diff and then it's causing a crash, then maybe your coworkers should wait until you fix the crash and then review it, right? So they would save time. And we want it to be part of continuous integration. So we want to, every time you submit a diff, you submit an update, we run again, right? We just want to constantly be running. And we also want to execute in parallel, because there's hundreds of thousands. So for example, in Facebook, there's hundreds of thousands of commits per week. And you need to test all of them, and you need to test them thoroughly. So you need to execute in parallel, otherwise we're not going to be able to test everything. So like I said, while we're exploring the application, we also try to learn something about it. So we learn about like Well, right now we're at the stage where we're just logging everything, and then we will think about approaches to like make use of that. But basically, like, what are all the things you've seen in terms of views? What types? What are the shapes? Is there something like we can learn about the structure of a specific app? Like, okay, this always appears at the top, so it seems to be a menu. Either start with it or ignore it, like based on what you want to do. If I do these things, then in logcat you have all these like exceptions, right? So we are looking at crashes, but also there's a lot of other things. So the main thing we look at is crashes, but you can also look at the logs and kind of collect, we do exceptions, soft errors, strict mode violations. We also detect ANRs. So when the application is not responding, we detect those and save like whatever dump is. So we actually hook into the activity manager, and then whatever it can see, we see. So any like switches of any ANRs or crashes that the operating system sees, then we just log those and then just publish them somewhere. So either we can triage to a specific diff, or we just, just create a task and find someone who seems to have worked on that file a lot or something. So it's two processes. So there's runs that run on master that try to understand the app and create these sequences and save them, right? Evaluate them and save them. And then there's but when someone submits a diff, you don't want to do this whole evolutionary algorithm and run for like half an hour to try to cover the whole app, right? So you just kind of go back and select. So from the learning process, from the evolutionary process where you're trying to generate test sequences, you save the test cases with all the information about them, like what did they cover, what happened, did they crash or not, like everything you found. And then when you want to test a diff, then you can use that information to decide which sequences you want to run on that diff. So obviously, you want sequences that cover the same lines of code that changed, right? So that's like one criteria. And also, you can have other criteria. So it's two phases. So we have two kind of modes of running. One is generating the sequences, so learning about the app and creating the sequences, and then one that just selects from the repository and tests the app when someone does a code change. And the way it works is like we have Fabricator, which is our like code collaboration tool, and the engineer submits their diff and it's there, and then the reviewer can see and review and stuff. And actually, like every time someone submits a diff, then the continuous integration process like automatically picks it up and creates a smoke build, right, for just that diff with master. And then we can straight away just run on that, right? So it's already been created because they have to run unit tests and all like the integration tests, E2E tests. So it's in place already. So all we do is like we wait on that queue, and every time there's a new build, we take it and run Sapiens on it. We know, of course, which diff because that's all in the data, and then we can, if we find the crash, we can just go back to, like I said, go back to the diff and comment on it. But sometimes we find a crash that is actually not caused by the diff, so we still might comment on diffs that have been closed, like landed a long time ago or something, just so that the developer knows that that probably caused the crash and maybe they would fix it. And we found that people do, especially if it's clear, like if it's clear, like there's a null pointer exception, which is quite common for some reason. Then they just put like if null, do something else. I don't know. So that they fix it. So we did like find that out of all the things we report, there's like a 75% fix rate, right? But you have to think about this in a different way. It's like, what if we didn't say anything? Would they still have fixed it, right? So it's not, so to kind of quantify what is the value we added is a bit tricky because they might have fixed it anyway, right? So what, like if there's a bug and someone faces it, then someone's going to fix it. But at least we saw some evidence that when we comment on something, it gets fixed earlier, which is the whole thing, like going back to this kind of we want to push finding crashes at code review point, not at in prod, right? So we found that actually we find a lot of crashes before the diff is landed and people fix them. So that's like definitely us, right? Because they didn't go to, okay, not definitely us. They might have tested manually and found it, but more confident that it's us. It's quite hard to, that's the thing, it's quite hard to know what impact you are having unless you have like amazing impact. There's 0 crashes in prod suddenly, right? So then you know, okay, it's us, must be, right? But we aren't there yet, basically. But we hope to be soon. So it's just kind of, we have these, I think it's 1,200 or so, I don't remember, but like 1,000 or something emulators just running constantly. Like every 10 minutes, it's testing another diff. So it's just, and if it finishes all the diffs that are there, it just starts again. It tests it twice, 3 times, selects other tests or something. So it's just constantly running. Because, like I said, when we have hundreds of thousands of commits every week, you have to have hundreds of emulators to test them. Otherwise, your queue will just go crazy and you'll everything is blocked. So last year was like completely like, okay, let's deploy on Facebook, the Facebook app, and make sure everything works. There's a lot of tricky things to think about, how to stop it from interacting with prod entities, prod users, or so like you have to put a wall so to stop any effect on prod. You also have to like think about test users, login, flakiness in the like for example, if you log into Facebook, every time you get a different login screen, right? So sometimes it's you put the username in and then next and then the password. Sometimes it's both. For some reason they have like 10 ways of logging in, right? So if someone comes up with a new way and we don't have it in our list of like, then everything kind of breaks and you have to. So we had to work through a lot of things to make sure that if someone changes something, we know really quickly so that our tests don't fail without, and we have to have a lot of hooks and data into the whole thing so that if we don't find crashes for a while, we know why. We know, are we actually logging in and are we testing the app, or is something breaking before that? So we spent a lot of time on trying to get Facebook to work. And then we onboarded others, so also like last half, was more like let's onboard all the apps. So we have, it's running on Messenger, Instagram, Workplace, also Work Chat and FB Lite. And we is kind of experimenting with WhatsApp. Yeah. But this half is more like, so what we think, no, so that's why we went back to, no, we want 100% reproducible. So we don't want to go on more apps or more flavors of the apps. We actually also run on iOS for the Facebook app. So instead of, okay, let's apply it to all the other iOS apps or Windows or something, we thought let's instead go back to the foundations and make sure our tests are 100% reproducible and that the coverage is like high. We're hoping to get to like, maybe let's cover 80% of branches or 100%, okay, maybe not. But 100% of branches in the app by the end of this year, hopefully. Yeah, you have to think about what's executable, because there's a lot of code that is not executable. It's like dead code or something, so it's kind of understand what are we covering. And so first of all, understand what is causing flakiness, and it might be something specific for each different app. And then on the other hand, why are we not covering everything, and how can we increase coverage? What are the things that I'm missing? Because there might be things that have nothing to do with your inputs, right? Like I said, the environment. So if you start with a user that has a lot of friends and has posts on Marketplace and has things to sell on Marketplace and has joined groups and stuff, and you start testing using that user, it's different to a fresh user with nothing, right? The things you can do. So it's like the setup of the the user. Like we can maybe set up a rich user before we start testing. But there are other things also that affect, like we said, like different devices, different combinations of operating systems and devices, and different capacities of the phone. Like if memory is low, maybe some other code gets executed or something. So there's a lot to think about in terms of how do you cover everything in the app. So this is like where we are right now, but also last half we had this experiment where we thought about like, let's auto-fix, right? So because when we looked, I forgot to include that slide, but when we looked at like the top things we found like 10% or actually maybe, I don't remember, 30% or something was null pointer exceptions. That doesn't mean that these are, and also we ran on, because like I said, it's a research project. It started as a research project. So they ran the tool before they joined Facebook. They ran the tool on 1,000 apps from Google Play, right? And then also looked at the distribution. And it turns out null pointer exceptions are like the highest thing we find. So it could be something to do with the tool itself. It's a bit dumb, so it just finds these easy things, right? But it's fine, because if we find them easily, users will find them easily as well. So let's fix them first and then think about something more complex. But then if you think about null pointer exceptions, maybe we can fix them automatically, right? Maybe it's, so this was like a project, right? An intern project. So here's the workflow. Once Sapiens finds a crash and finds the diff that it thinks caused it and comments on the line, then this auto-fix thing is triggered. It will take that code and then apply different patches to it. So it has 4 strategies to fix a crash. The main one is templates, right? So like I said, there's this other team called Infer that does static analysis and stuff, and they did analysis of all the fixes people do for bugs and stuff in the past year or something. I don't remember the details of what they did, but they analyzed what are the patterns that people do as fixes, and then they created these templates that you can just apply to the code, and it will fix it, right? So we use templates. That's one strategy. So we just kind of try to see, are any of the templates we have applicable here? Do they go with this thing? Then apply them, right? So then you would have a few patches from that, or maybe one. And then another approach is mutation. It's a bit stupid at this point. So it just kind of takes one thing, changes it. So it was greater than, makes it less than, makes it greater than or equal, or something like small, just one thing and changes it, or removes a line or adds a line. There's a lot of research. If you look at papers and stuff in academia, there's a lot of research on these approaches, and they found that it could fix things sometimes, but it's a long way away from being useful. But we thought we'll add it, why not, right? So we have this strategy. And then there's just like straightforward revert the diff or revert the lines that caused the crash, if it's possible to revert them separately. These 2 cases we only do if it causes an insta crash. So if every time you open the app it crashes, then because of this diff, then we could just revert the diff, right? They can figure out what the reason is later, so you just want to fix as soon as possible. So anyway, so we apply the 4 patch generation patterns, and then this will each one will create a revision. And so as if this tool is now submitting 10 diffs or something with the 10 different things it applied. So it will create revisions for each one of them, and then you'll have all of these patches. And then once it compiles, it builds them. So the system automatically, right, that the continuous integration will pick them up, build them, and then some of them will fail. Like it can't even build it, can't compile it because you did something stupid with the mutation approach or something. So we'll drop those, right? So it's like a filtering process. First, these go. And then after that, we would run Sapiens again on these, the ones that survived. We'll run Sapiens again. If it finds the same crash again, that patch is dead, right? So it's kind of just keep the ones where it didn't find the same crash. And this is why reproducibility is important, right? Because we found that when we did this experiment that, oh, sometimes it doesn't find the crash, but it's actually the crash is still there, it didn't fix it, but just that run didn't find it, right? So that's why we went back to working on reproducibility. And then we also run all like the integration tests, end-to-end, everything. Any manual tests that exist that touch that code, we run them as well. If it passes all of that, then it can be published as a diff, ready to be reviewed by the other developers, right? So we add the developer that, so like I said, Sapiens finds a diff that it says this diff probably caused the crash, so we will put that developer as the reviewer of our automatically generated diff. And then if they find that it's okay and accept it, so from there on, it's like any other diff. So the developers have to review it and decide if it's correct or not, and then we will just track that. And once they accept, we'll land. And if they reject, we will, of course, abandon. And if they don't accept for 3 days, we think that that's okay, that's now outdated. So we just also abandon. So we don't wait indefinitely. It's just 3 days. If they don't accept it, then it's probably not good. So we just kind of drop it. Yeah, so once it's accepted, it's... yeah, so that's it. So... like I said, we have to think about reproducibility and stuff to be able to do something. And this whole fixing thing is really like just basic right now. It's mostly these null pointer exception things. But I think it's the first step to trying to do something more smart maybe in the future. Thank you for listening. Yeah? I'm sorry?
Do you run the applications end-to-end?
The applications, yes, yeah.
So you're all running in the full environment? Okay, that's one question. And the second question is, if you have a diff, do you analyze what the impact is on the functionality, or just do random testing?
No, right now we don't look at, it's something interesting to us that we want to look at, but we don't look if the functionality is correct, because it's really hard to do that automatically, right? But it's something we have some ideas about. Like, for example, you can have general constraints, right? So you can say, like, the screen should never be empty. This bottom part should never be blank, right? I don't want to see any pictures that are broken, or something like this. Like, okay, these are like silly examples I gave, but you can think of, like, you can have general constraints. Like, I don't want to see this type of thing in general, right? There's another idea that is, if we take unit tests and try to generalize what they're trying to test, right? And then take it all the way up. It's a bit, no one tried, like we didn't try it, probably not able to do. But someone did some work a bit related, like take the unit tests and then try to generalize what are the constraints from that, right? Code coverage, so branch coverage of branch coverage of the code, like on the bytecode level, like every if statement and ×2 sort of thing.
You mentioned that you have to write the specific logic for some flows, but also that the Sapiens learns itself. To which extent do you actually have to write the boring part, and to which extent is the learning process, and is the learning supervised or unsupervised?
The logic, the bits we write, like in detail, are usually just the login, because it's just like if it doesn't log in, it's not going to work, right? But the other things are a bit generic, so that they can apply to all apps. So, for example, like if you see a box, put text in and then press a button. These are more generic. So if you write them once, they will work for all the apps, right? So. But the learning we do is just more like now manual. It's not machine learning. So we just kind of save what did we see and then inspect it and then think, oh, now let's add logic that goes back to a point that had a lot of potential and click more. So it's still like not at the level of machine learning or something smart. I'm sorry, I didn't.
Also Aroma, right? From Facebook.
Aroma.
Aroma.
Uh,
It's not integrated, I think.
is it for apps or for? I'll have to. I'm sorry. I have to. I don't know it, which is strange. So I'll have to check straight away. But I'm sorry.
It was at FX.
Ah, okay, okay. Yeah, I'll check it right now. I'll check and let you know. Any other questions? Go on. So the prototype, the research prototype is available online. You can download it, but we did move like a long way after that. But we have plans to open source, but we are just kind of not. We want to fix all these issues before we open source it. Any other questions? Okay. Thank you very much for being here. Thanks.